Today we are going to solve Leetcode 209, that is minimum size subarray sum. In this question we are provided with nums array and a target value, and we have to return a minimal length of a subarray whose sum is greater than or equal to target. And if in case there is no such subarray, then we have to return 0 instead. So how we can solve this question? Like we all can see, this is the nums array and we are asked to return a subarray whose sum is equivalent to the target or greater than. So we can see that these are the two subarrays, right? And we can see that this one is having the minimum length in comparison to this one. So what will be the output? Output will be 2 length of this subarray. So if we are going to solve this question using a brute force approach, we can easily use two nested loops and we can calculate all the subarrays and their total, and we can return the minimum length one. But that is not required. As we can see, if we are going to solve this question using this approach, after a point of time the sum is going to become greater than our target, and after that point the sum will keep on increasing, and so the subarray's length, and we don't want that. What we want is the sum has to be equivalent or greater than target, but the length of the subarray should be the smallest one, minimum one. So how we can solve it without using or without calculating all the subarrays? So we can see that we can solve this question using sliding window approach. Now what is sliding window approach? Sliding window approach is such that where we have two pointers, where these two pointers represent the starting and the ending point of the array, and we initialize these two pointers at 0, and then we keep on increasing the right pointer and the left pointer as per our requirement. So how we can utilize this approach to solve this question? Let's see. So firstly, let's initialize our left and right pointer. So left and right pointer are equivalent to 0 right now. So they are here, right? So at this point, what will be the sum of our window screen? Sum is 2 because both the pointers are at this place. And what is the resultant length? So for now, let's keep it infinity. For now, let's keep it infinity, because what we have to return the minimum length, right? So as and when our window size is going to increase, we will update this resultant length. For now, let's keep it infinity. So now let's increase our right pointer. So right now our left is at this place. Now we are going to increase our right pointer. So what will be the sum? Sum will be increased by 3. So sum will become 5, right? Sum will become 5, and we can see that 5 is lesser than 7. So because 5 is lesser than 7, so we don't have to update our result, right? We can proceed with this sum value. So we will proceed. Now we will again update our right pointer and it will go to 1. So now what will be the sum? Sum will be 6, which is still lesser than 7. So we will again increase our right pointer, update our right pointer, and it will go to this place. Now what will be the sum? Sum is 8. Now we can see that 8 is greater than our target value, right? Is greater than 7. So what we can do? We can update our resultant length with the window size, and also we can update the left pointer, because now we have to reduce the left pointer so that we can change the window size, because our sum is greater than the target value. So let's do that. So at this place our resultant length will be minimum of the previous value, that is infinity, and the current value. What is the current value? Current value is right minus left plus 1. This will be the window size. So window size is 4. So resultant will become 4, right? Let me just clear this. So our resultant, let's just denote it by R. Our resultant length is 4. Okay, so now we have updated our resultant length, but we also have to update our left pointer because our sum is already greater than the target value. So what we will do, we will update our left pointer and we will move it by 1. So the left pointer will go to this place. And same time what we are going to do, we are going to update our sum, and what we will do, we will subtract that value which was at left. So this will be 8 minus 2, it will become 6. So now our sum is updated, our result is updated, and our left pointer is also updated. So now what is the sum? Sum is 6, which is lesser than the target value, right? So what we will do, we will again update our right pointer. So our right pointer will go to 4. Now again what we will do, we will update our sum. So this will be 6 plus 4 and this will become 10. Now we can see again the 10 is greater than our target value. So now what we have to do, we have to again update the result, left pointer and sum. So result will become what? Still the window size is 4, so result will be 4. Sum will be total of sum minus the value which is at left, so that is 3. So this will become 7. And then what we have to do, we have to update our left pointer. Left pointer will go to this place, right? Now we can see that the sum is 7, which is equivalent to target value, right? So what we have to do, we have to repeat this step again. So what we have to do, we have to again repeat the we have to again update the result. So result will become what? We can see that now the window size is 3. So as we already know that we are taking the minimum value, so it will become 3. Sum will be again 7 minus the value which is at left, so it will become 6. And again we will update our left pointer. Left pointer will go to this place. Now we can see that the sum is 6, which is lesser than the target value. We know that when sum is lesser than the target value, then we have to update our right pointer. So now our right pointer is here. So now what will be the sum? Sum will become 6 plus 3, so it will become 9. We know that 9 is greater than the target value. So now what we have to do, we have to again update our result. So result will become minimum of window's length. So right now we can see that window size is still 3, so we don't have to update it. Resultant length will be same, and what we have to do, we have to subtract the left pointer's value, that is 9 minus 2, so this will become 7. And then what we have to do, we have to again update our left pointer. Left pointer will go to this place. Now what is the sum? We can see that sum is equivalent to 7, right? So again we have to do the same thing. Again we will update our result. Now we can see that the window size is 2, which is lesser than the 3. So we will update our resultant length because we have to keep the minimum value. Now again we will update the sum, so it will go 7 minus value at left pointer is 4. This will become 3. Now what we have to do, we have to update our left pointer. So our left pointer will move to this place. Now we can see our left pointer is equivalent to the right pointer. So we know that we reached the end of the array. Now we don't have to proceed. So we will return what? We will return the value which is with R. So that is 2. So our output is 2. So the minimum length of the subarray which was equivalent or greater than the target value was 2, which is this one. So this was the whole algorithm, and we are going to code this whole solution. And let's see how we can do this. So as we already saw, firstly we have to initialize our left and right pointer. So this is 0 0, and we are also having a variable which is going to hold our total sum of our window. So that is also 0, and there will be a resultant which we know we are going to keep equivalent to the largest value because we are going to update it with the minimum value. And after this, what we have to do, we will iterate over the nums array for write in range length of nums. In this, what we were doing, firstly we are updating our sum window, and this will become what? This will be increased by the right pointer's value. After this, we are going to check if the sum value is greater than or equivalent to target, then update our result first. So what we were doing, we were keeping the minimum value of resultant and the current window size, that is this. And after this, what we were doing, we were subtracting the value from our total. This will become nums right will be subtracted, and after this what we have to do, we have to update our left pointer. Oh, this will be left. We are subtracting the value which is at left. This loop will run to the point this condition is true. So when we are in that situation where our sum of the window is lesser than the target, then only we are going to proceed and update our right pointer. So after getting out of this loop, what we are doing, we are going to say return result if resultant is not equivalent to the value which I initialized it previously. So what was it? Infinity. And if it is equivalent, then simply return 0. So now let's check what I did. Oh, this is right and this is left. Okay, so I think this is working. Yeah, we can see this code is working and is efficient. So let's try to analyze its time complexity. Now, as we already saw our code, so we can check what's the time complexity of this whole approach. So the time complexity is equivalent to big O of n. Now you must be thinking that we are using two loops, that is, one is for right pointer and then second one is for left, but we are not running this second loop for every iteration of the first loop or the outer loop, I would say. We are not running this inner loop for every iteration or each iteration of the outer loop. Therefore, the time complexity won't be big O of n square. And secondly, if you are going to read about sliding window approach, it guarantees that at max we are going to have 2n window iteration. So by this, we can say that we are always going to have time complexity equivalent to this. And also in sliding window approach, the time complexity analysis is usually done using amortized analysis, which is, if I have to explain it, then I would say it is simply a aggregated form of analysis in which we are more focused on the average case scenarios rather than considering worst case scenarios. So for that reason, the time complexity is big O of n and the space complexity is big O of 1. As we hadn't utilized any data structure, we only used all the variables like left, sum, result. All these are variables and they'll be constant. So the time complexity is big O of n and the space complexity is big O of 1. So this was the whole solution, and I hope this video was helpful. And if you find this video helpful, then you can like this video, subscribe my channel, and I will soon come up with few more questions. Till then, keep watching and thanks for watching.